Hello, I am Anelka, a first-year student in the Networks and Telecommunication Bachelors of Technology, and today I'm going to present my project. This project is based on the STM32WB55RG board, but since I'm a bit lazy and its full name is very long to repeat, I will simply call it the WB board for the rest of this presentation. It is a system I developed to collect environmental data and display it in the real time on the dashboard using a BLE or Bluetooth Low Energy. The main goal of this project was to take data from external or internal sensors, then transmit this data to another device. First, I will show you how the system works. Here we have the WB board connected to the sensors, and here we can directly see the data being captured in the real time on the screen. I'm using OBS to display the values received from the board. As you can see, the dashboard receiving the data, but the value quite stable, so we don't see much variation. To create some change, I will run a program in the background, like Tekken 8. A little shout out to those who know. This will use a lot of CPU and generate heat, and the fan will push warm air out of the computer. I place the sensor near the fan so I receive the warm air. This allows me to see more variation in the data. And this is what allows me to observe the change in the real time on the dashboard. The data is collected and sent via BLE. On the server, a Python script receives the data and processes it. Then the data is stored and made available to the web page. Finally, the dashboard displays the data in the real time, and this is how the system works globally. Wait, I never say the name of the project. Let me fix that. The project name is the Flemmosta. The name comes from combination of thermostat and the French word flemme, which means laziness. It is also inspired by Gaston Lagaffe, a character everyone knows for his laziness. The system is based on the WB board. As you can see here, is the main component of this project. This board integrates Bluetooth Low Energy, which allows wireless communication. I also use this sensor here, which is DHT11. It is used to measure temperature and humidity. In addition to that, I use the internal temperature sensor of microcontroller. I know it exists and works, but I was not able to precisely locate it on the board used. This system is structured in the three main parts. First, the WB board reads the sensors, processes the data and sends via BLE. Then a Python script on the computer receives the data, converts it into JSON and stores it. Finally, a web dashboard reads this data and displays it in the real time. One of most interesting challenge I faced was to relate to the internal temperature sensors. The measured values were inconsistent, sometimes very low or even negatives. These issues come from the analog to digital conversion. The ADC converts a voltage into digital value, but the conversion depends on the reference voltage. In my case, the sensors is calibrated at 3 volt, while the board operates around 3.3 volts. This difference affects the measure scales, which explains the incorrect value. After applying a correction factor based on the difference, I was able to obtain a consistent result. For the conclusion, this project helped me to understand how to design a complete IoT systems, from the data acquisition to the real-time visualization. It also allows me to work with embedded systems, BLE, communication, and data processing. Through this project, I gained a better understanding of hardware and software interact in the real-world application. That's it. Thank you for your watching.